Okay, the absolute value of y plus 3 is greater than 4. Remember, just ignore the y plus 3 for a second. I have something, the absolute value of something. Something's distance away from 0 is more than 4 units away. So if I start at 0 and I go to 4, nothing in here will work because that's too close, right? It's too close to home, okay? Now, anything out here would work, right? Because that's more than 4 steps away from 0. Could I be at 4? No, because it has to be greater than 4, right? If I want to be more than 2 hours away, if I go somewhere that's 2 hours away, that's not more than 2 hours away, that's 2 hours away, okay? So not going to include the 4, or I could go left and I could go to -4. Once again, nothing in this area is going to work. Anything out here, and if I keep going left, any of that will work, but once again, -4 is not going to work because that's not more than 4 steps away. It is 4 steps away, okay? Just like yesterday, what this means, what this first graph means, the absolute value of something is more than 4. Whatever's inside here could be equal to any number in this shaded area, or it could be equal to any number in this shaded area, okay? So I have to write an inequality showing that y plus 3 could be any number less than -4, or y plus 3 could be any number greater than 4. So we're just going to write that down. Whatever's inside there, which happens to be y plus 3, could be anything, any of these numbers. All of these numbers are less than -4. Or, today they're all going to be or statements. Whatever was inside there could be any number in this shaded area, and all of these numbers are greater than 4. Yes?
Could you have those looked around?
You could. So if you wanted to do this one first, absolutely. Doesn't matter. Okay? So now we have to solve both of them. So once again, kind of like yesterday, how we followed the same steps for both of them, we're going to follow the same steps for these two. So we're going to subtract 3 from both sides. So I have y is less than -7, or y is greater than 1. And then just like yesterday, I have to graph my actual solution set. So this is your answer, and then you have to graph your answer. So I'm going to have a dot at -7 and a dot at 1. I need to show the numbers that are less than -7, so we'll have an open dot at 7, shaded to the left. And then I need to show the numbers that are greater than 1, so we'll have an open dot at 1, shaded to the right. Okay, once again, just like yesterday, I should be able to pick any number in that shaded area. It should work. So, let's look at this left-hand shaded area. Any number less than -7. What is the number in this shaded area? -11. So if I plug -11 in here, it should work. So, -11 plus 3 gives me what? -8. What's the absolute value of -8? 8. Is 8 greater than 4?
Yes.
Yeah. Okay, now, since this isn't shaded, I should be able to pick anything in here, and it shouldn't work. What's the number inside here? 6. 6? No? In the not shaded area? In between -7 and 1? 0. 0 is a great number, right? 0 plus 3 gives me? 3. What's the absolute value of 3? 3. Is 3 greater than 4? No, it doesn't work. It doesn't work. Okay, and then now we could use 6 for this right-handed region. This one should work. 6 plus 3 gives me? 9. The absolute value of 9 is? 9. Is 9 greater than 4? Okay, everybody see that? Okay, let's try another one. Okay, number 2. Let's try the absolute value of z minus 2 is greater than or equal to 3. Okay, we are going to draw that first graph, although I'm already telling you today that they're all going to be disjunctions. I do want you to draw that first graph. So I need to show that the absolute value of something is more than 3. Something is more than 3 steps away from 0, or could be 3 this time, right? So once again, can't be anything in here. This time, I could go to 3, right? Because it's greater than or equal to 3. or further than 3. Or I could be at negative 3 or further to the left of 3. Okay? It'll catch up eventually. Okay, so once again, I need to write an inequality showing that whatever was inside here could be any number in this shaded area or this shaded area. So, z minus 2, because that's what inside my absolute value. How would you express this half of the inequality? What are these numbers? These are the numbers less than or equal to negative 3. Or whatever was inside that inequality absolute value could be any number in this shaded area. What is this shaded area? What are these numbers here? Greater than or equal to what? 3. Very good. Very good. And then we need to go through and solve both of these. So on your paper, I want you to go through. And graph it. Should end up with something similar to this, or really not similar, should be this, right? Okay. Should have z is less than or equal to negative 1, which means a closed dot at negative 1 shaded to the left. Since it's an or, remember, we shade any possible solutions. So we're going to shade to the left of negative 1. We're also going to shade in 5 and to the right of 5 because I had z is greater than or equal to 5. Okay, make sense? Yeah. Really the exact same thing we did yesterday, right? Okay, all right, well, good deal. We'll try one more together because it's kind of a tricky one. And I'll have you guys try the last 3 on your own, okay? Let's try the absolute value of 3 minus 2y is greater than or equal to 5. Okay, so once again, we need to draw our little mini graph. So something, ignore the 3 minus 2y, I don't care what's inside there for this first graph. Something is more than or equal to 5 units away from 0. So I could be at 5 or further than 5. Or I could be at negative 5 or further than negative 5. Nothing in between though. Okay. And now I need to show that 3 minus 2y could be any number in here, or it could be any number in here. So 3 minus 2y could be any number less than or equal to negative 5, or 3 minus 2y could be any number greater than or equal to 5. Okay, one thing I want to remind you guys of, I've already mentioned it, we follow the same steps for both of these because it's the same expression on that left-hand side. So keep in mind, we're doing the same thing for both of these. So let's start here. What would you do first to solve for y? Subtract 3. Very good, very good. So I'm going to go ahead and solve both of them at the same time because this is kind of a tricky one that we only have to really kind of think about it once. So now I have a negative 2y is less than or equal to negative 5, and I have a negative 2y is greater than or equal to 3. Okay, then what would you do? Divide by negative 2. What happens if you multiply or divide both sides of an inequality by a negative number? Have to flip the sign, have to remember that, So I have y is greater than or equal to, and a negative 5/2 over a negative 5/2 is what kind of number? A negative over a negative. So I have a positive 5/2, or y could be any number less than or equal to, because I have to flip the sign here too.
You forgot to subtract 3 from 5.
I was going to say, I thought I ended up with a whole number. Thank you, guys. That's what you're here for, right? Call me out on my mistakes. Minus 3. There we go. So negative 2y is less than or equal to negative 8. Divide by negative 2, we still have to flip the sign. So y is greater than or equal to a positive 4, right? Yeah, I didn't do it over there either. Okay, so that should be a 2. And then 2 over negative 2 is a negative 1. Once again, you have to flip the signs both places. Okay, now another thing you kind of need to be on the lookout for if you have to flip the signs, it may not go in the same order. So usually on the number line we put this number and then we put this number. But notice that we still have to draw a number line correctly. -1 is to the left of 4. So you may have to flip those two. Okay, so just kind of being on the lookout. Okay, so if y is greater than or equal to 4, I need a closed dot at 4, shaded to the right. Or y is less than or equal to 1, a closed dot shaded to the left. Make sense? Okay, I'll have you guys try this one all on your own. Okay, I want you guys to try the absolute value of 4y minus 12 is greater than 16. Okay, hopefully we had that right first graph. The absolute value of something is more than 16. So whenever you make that first graph, we should have our combined inequality, 4y minus 12 is less than negative 16, or 4y minus 12 is greater than 16. When you solve the first one, should have y is less than negative 1. Or when you solve the second one, should be y is greater than 7, which means your graph would look like this. Any questions on that one? Okay, I'm going to put the last two on the board at the same time. I want you guys to try both of them. Okay? So number 5, be really careful on this one. The absolute value of 3 minus x is greater than or equal to 10. And number 6, the absolute value of 5r minus 4 is greater than 16.